Hello guys and welcome back to my channel Civil Construction and Tutor, and in this video I will show you how to design various types of footing using a single Excel sheet. Starting with different types of Excel that is footing, that is isolated footing, and then we have strap footing that is with the 2 columns, and strap footing with 3 columns, combined footing for 2 columns, and combined footing with 3 columns, and finally the mat. And this sloped and pad footing is for the exit, that is the isolated footing. I've already uploaded a bunch of videos regarding design of the footing using Excel sheet, and I've already shown how to prepare them as well. As I've already shown you how to prepare this Excel sheet on your own, else you can purchase this Excel sheet. For this Excel sheet you can simply click on the link in the description box and request for the access, and you will get a mail from us regarding the payment procedure. And these Excel sheet are paid resources, so do not request for free access because 20% of the payment you make goes for the treatment of the financially disadvantaged patients. So on this note, let's start the designing. So basically in this video I will show you how to use all those Excel sheet in a short video. So considering this building, we'll be using all the types of footing for the base reaction that it is getting. So for this, simply we'll go to the base reaction here and select apply. Okay, and we'll go to the plan view, and for now let us provide a mat footing for this staircase section, that is for this 4 columns, and we'll provide a strap footing for this. Similarly, combined footing over here, and axial footing, that is a simple isolated footing over here. So let us provide an axial footing for the maximum load. Let us provide any type of loading. For example, we'll be providing an isolated footing over here, and the reaction here is 314. You can also check for the mx and my, but generally it is quite small as compared to the value, so we can just ignore this. So apply, and we'll be taking this 314, and remember this is a service load, that is on factor load. So going back to the Excel sheet in the isolated one, so here isolated footing, so the yellow cells are only to be filled considering the grade of concrete for footing as M20, so it will be 20, grade of steel 500. This is angle of friction, so basically this is used for computing the depth of footing. So angle of friction generally 30°, or you can also check the soil report. Allowable bearing pressure at site, so it is also taken from the soil report, so it may vary. For now let us assume this to be as 120, that will be okay. This is the unit weight of soil. For now let us keep this as 16. This is the D dash, this is clear cover, so 50 mm, and this is the, here you can also find the thickness of footing at the edge. So if we are providing a slope type of footing, then you will see that we'll go in the trapezoidal shape. So the minimum depth at the base is basically the edge depth, and this should be minimum 200 mm. So for now let us keep this as 200 mm or 8 inch, and this will be the effective edge depth 150. Maximum column diameter, so this will be used for calculating the development length of column and the availability of the space due to the width of the width or length of the footing, and offset at top. So if we are providing a trapezoidal shape, then at the top, that is the column and footing intersection, that will be the offset, so from the face of the column, and minimum it should be 4 inches, and that is 100 mm. So okay, now let us come to the ID. So we'll enter the data in the yellow cells only, and from the node you can simply put this as B3. So this node B3, and load 314 point something, so round off 315. Let us keep this moment and about x and y as 0. If we keep this value also it is okay, but for now it is very less, so we can ignore this. And width and depth of column, so it is 14 inches column, so 355 depth required. So this will depend upon the angle of friction of the soil and allowable capacity of soil and unit weight of soil. So this comes as 0.83, and we'll provide accordingly over here. So these are the required footing sizes, and these are the provided footing sizes. So I have computed in feet and meter as well, and required area we get this value. So the required footing size is 1.7 meter and 1.7 meter considering a square footing, and in case of feet this will be 5.58 feet. Now provided size of footing, so 1.8 meter, so I have provided minimum value of 1.8. Similarly, depth of footing 5.8 considering round off, that is ceiling, I have provided here over ceiling, that is 0.25 and 5.8. and converting this into meter, 1.8 and 1.8. And depth required is 215 mm. So provided depth we can simply provide as 400 mm. So this is on the basis of moment. So considering this shear will provide a greater value, so for now let us provide as 400 mm. And rebar, so providing 12 mm rebar, spacing required is 314, so provided as 150 mm. For Fe500 minimum spacing to avoid cracking is 150 mm. And along traverse direction and along longitudinal direction, and similarly along traverse direction we can provide 12 mm as well, so we get 150 mm. And there is check for one way and two way shear, so it is also safe, that is okay. And finally we have development length, that is for the column of bar 20 mm and grade 20, size 20 mm. So available length, that is we have provided 1.8 meter, so accordingly we'll provide get 722 mm only. So vertical bar 415 mm to compute this or to cover up this development length. So check for LD is revised, that means we have to provide vertical offsets, so that is okay. Now coming to this page, this will be the annex. So if you want to check the calculation, I have provided over here, and you can check over here. And finally we have the report. So if we are providing slope that is footing with edge, that is offset, so then you can directly copy this and paste it in the report. So that will be the final thing. Here you can see footing summary, length, width, depth, edge depth, and depth from ground level, and reverse summary 12 mm at 150 and 150. Similarly in case of pad footing, it will be computed without any edge depth, and that differs in one sense, that is for slope footing the depth is governed by bending moment rather than shear, as resisting width for moment is smaller than the shear force. So that will be the difference. In this way we can design the isolated footing. Now let us go for the strap footing. So considering two columns, let us select this one rather. So 164 and 223. So let us go to the Excel sheet over here, strap footing two columns, and I am considering A4 and B4. A4, B4. Grade of concrete 20, 500, allowable let us assume 120, clear cover 20, size of column 0.35, center to center distance between these two, so 3.73. And we'll be providing load on the left edge column and load on the central column. So one of this will be the central and this will be the edge, 165 and 225, let us assume 165 225. So total column load, and we have to give the value, that is the width. So you can see here total length required 1.63, so the length is very small, so we can go for a smaller width over here, 1.8. We can also go for a smaller value, so 5 feet, and we'll get 1.09 and 1.22. so this should be sufficient, providing 5 feet by 5 feet. So we'll provide a round up value, 3.5 feet will not be sufficient according to the site conditions, so we'll be providing 5 feet by 5 feet. And again over here, depth required according to shear force, depth required according to moment, so providing a maximum value of these two, let us provide 350 mm. And bar size is 12, so this is to be changed over here if you want. So 12 mm bar at 150, and that gives the result as safe. So you can also provide as 16, 16, and over here 100, 100, whatever you want, but for now 12 mm is sufficient with 150 mm spacing. And similarly now this beam has to be designed upward reaction, so I will not explain all these things, I'll just enter the data over here. Width of the beam, generally it is kept equal to that of the width of column, so 355, that means 0.35 meter. Required depth of beam 340, so let us provide a slightly greater value, so this is the effective depth. So over here come and provide 400, so this gives 360, which is greater than 340. That should be sufficient. Area still required 832, so simply 5 number of 16 mm bar, that gives a area of 1005 mm square. Okay, similarly for the bottom, this will be the top reinforcement, and for the sagging moment, 667. So going for 3 numbers of 16 mm bar and 2 numbers of 12 mm bar, this gives 829, and that is okay. For shear reinforcement, we will be considering the minimum reinforcement that should be sufficient for the strap footing. So considering 10 mm vertical, 10 mm diameter of steel ups and number of legs 2, so we get 150 mm as the spacing, and the final summary will be footing slab length, width and thickness for the edge, for the central, for the and strap it is 1.09, will provide 1.5 mm anyway. Strap beam 355 and 400 mm, and the longitudinal reinforcement and the shear reinforcement. So in this way you can define we can design strap footing for 2 columns. Now coming to 3 columns, so there might be a case where 2 sides of the building are flush to the property line. So assuming that this will be the central and this will be the edge columns, so 164, 225 and 170, so we'll design for it, and this will be A4, B4 and C4. 20, the grade of concrete will be same, we'll be considering 20 mm, grade of steel 500, allowable bearing capacity let us assume as 120, clear cover 50, size of column 0.35. okay, center to center distance that should be taken from ETABS as well, 3.73 and 3.88, 3.73 and 3.88. okay, load on the edge column 165, 225 and 170, 165, 225 and 170, and we have to adopt with a footing, so let us go with 1.6, and that gives length of central footing as 1.8, and with respect to this 1.29, so providing this as well 1.6, so 1.6, and this is basically maximum of 1.5 or whatever value you want to give, so overall 1.5, that should be sufficient as well, I guess. So 1.5, 1.5, so it will be a square footing. Now other things remain same, that as according to strap 2 columns, so depth required, so we can go for 350 again, and accordingly you can provide the data, so 400. You can also go for a smaller beam if you want, for example you can go with 300 and reinforcement accordingly, and we will get this final summary as edge, central edge 1.5, 1.5, thickness 350 mm, reinforcement 12 mm bar at 150 mm both ways, that is longitudinal and transverse. And remember, for the strap footing, the main reinforcement for footing will be in transverse direction, because in this direction the beam is going to take care of the moment, and in this case we have designed for the cantilever portion over this direction, so the main reinforcement will be in this direction. Now coming to combined column, so in case if the bearing capacity is not satisfied, or we can say if the bearing capacity is very less, then we may go for combined footing, or even for taking care of the shear, so in this case we will be providing a combined footing. Now let us see the base reaction again. So for this 247 and 315, let us check 250 and 315. So the column size of A and B, remember the service load A, we are considering smaller one for this side and the other side as B, so you can put the data accordingly. Other things are almost same, so this will be 3.73, this will be 120. Let us assume if the bearing capacity is less, up to 90, then we can go for this. And in case if the property line is not flush, that if the footing or column is not flush to the property line, then we have to add this distance. For example, if we have an available space of 1 meter, then we can add the consideration, that is that the length available, and we have to additionally provide the length of footing, which is 6.52. That makes the sense of this arrangement. For now, let us assume that it is flush to the property line. Then required length of footing 4.52. So make sure that this length should be considered, because we are designing the footing considering that the center of gravity of the load and center of gravity of the footing coincides. So 4.52, and required width of footing is 1.53 with respect to this length of footing. Now the bearing is done. Longitudinal bending, that is for the reinforcement, and according to the moment, the required depth is 269, and will provide depth equal to 400 mm. That should be okay. And reinforcement required, this is mm square and this is mm square per meter, and 16 mm, or if we go for 12 mm, then it is not sufficient, and it will be automatically updated, and the minimum reinforcement spacing is 150 mm maximum, sorry. So 16 mm at 125 mm will be sufficient for us. Similarly, positive longitudinal reinforcement at bottom. So this is the main longitudinal reinforcement, positive longitudinal reinforcement. This is for top hogging moment, and we can go for 12 mm as well for the bottom, or we can provide same reinforcement. Transverse reinforcement will be a minimum reinforcement, that is for the temperature one. And let us see over here, shear check fails because we have no any projection over here, so the area, effective area for punching will be less, so that makes a little bit more critical. So in this case we can increase the footing depth, and it is still not, because nominal shear stress is 0.45, 0.41. we can go for a greater depth of footing. Let us assume 550 for now. So okay, check for one way shear is done, check for two way shear is also done. And finally the summary: grade of concrete M20, grade of steel Fe500, length and breadth, and finally depth of footing with reinforcement 16 mm bar at 150 mm center to center, as longitudinal reinforcement at top and bottom. So this will be the combined footing. Now coming to combined with three footings. In case if there is to be provided a combined footing with three columns, then we can use the data over here. So let us assume this as 355 and this as 355 and 2500 120. So again, for let us now it is 90 depth of footing, and this will be 3.73, 3.88. projection towards left from the face of column, no, and as we have already said, it is flush to the property line, and this will be the projection at the upper side and lower side. We'll do that. So now load. So the idea is almost similar to that of raft footing. I'll show you that. 250, 315 and 220. And this will be center corner, and this will be corner as well, because it is flush to the property line, there is no projection. And we can even say this as face column, rather it is a face column, because we have projection, or we have projection in the upper side and lower side of the column. So this will be face. Now let us see over here, the bearing pressure is done. Okay, live load, it will be 0. Strip and maximum moment, so we don't have any face columns, edge column, so it is NA. For face column, according to the maximum load, the depth required is 222, and from moment consideration, depth required is 248, and if there is any distance from the column face, then we have to give. For now it is 0, and 193, 222. So the maximum depth of 450 mm should be sufficient. So the depth provided is safe, and calculation of reinforcement. So again, longitudinal reinforcement and providing 12 bar. Okay, let's go for 16 bar and 150 center to center. Okay, transverse reinforcement will provide minimum reinforcement of 0.15 percentage. So for mat we'll go for 0.15% as a minimum reinforcement. And finally the summary, and finally we have mat footing. I've already shown a video regarding how to use this Excel sheet. So for now I'll just simply use for 4 numbers of column. You can add the number of columns accordingly. You can find the video in my YouTube channel how to add number of columns, and without doing very much, with simple inserting new rows you can design a mat footing. So for now let us consider this. So 355, 355, 20. Let us keep 120 kilonewton per meter square. Depth of footing along AB. So AB 3.73 and B0, this will be 0, and along 1, 2, 3, so it is 2.13. Projection towards left, so towards left it is 0, towards right we may have some projection because it is in the middle. For now let us keep this as 0 as well. We'll check if it is required or not. Projection at the upper side from the face of column, so this will be the upper side. So we also have projection over there, but in the downside we might not have because it is flush to the property line. So let us keep all the value as 0 and then we'll check. Total length of footing, we get these things, and number of span has to be added if there is no more than, for now it is 1 and 1 in either side. Now let us keep the load. So this will be A1, A2, B1, B2. 126 to 16. 126 to 16. Similarly 163 and 258. So accordingly this data will be added. For now this is also a corner column, 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 because we haven't provided any projections. So for corner columns it will be little bit critical in the case of bearing as well as shear check, that is punching shear. So coming over here, all things will be calculated, and live load, if it was a basement parking then we have provided certain live load. For now it will be 0. Self weight of footing 126.89 kilonewton. So in one of the case it is failing 157, this is B2, that means over here it is failing because the load is also greater 258. So we have to provide a projection. Let us provide projection in the upper face and the right face because it is also available in our condition. So towards right face let us provide a projection of 0.5 and towards upper side as well 0.5. Now let us see. So it is now okay, the bearing pressure over here it is okay. And similarly average stress computation, and we'll get the maximum moment, and from the moment consideration the maximum depth required is 261 mm. And similarly we'll check for the edge depth. As I have already said, we have edge column only, so we are not getting any data over here. So we'll check for the edge depth or edge column only, and the column load is 258 kilonewton, that is the maximum. Now as we have provided projection over here, so it will be a face column, we can consider them as face column. So only this will be edge column, other will be face. So we are getting 227 mm. So providing overall depth of 400 mm should be sufficient, and the depth provided will be sufficient against bending and two-way shear consideration. And for this maximum moment we can compute the reinforcement as 16 at 125, and the overall summary we get grade of concrete as M20, grade of steel as Fe500, and slab depth as 400 mm with 16 mm bar at 125 mm both ways. So I hope this video helped you, and if it did help, do like and comment in the video and share with your friends. And if you want this Excel sheet, just click on the link in the description box and you will get a mail from us regarding how to make the payment. And make sure this is a paid resource. I have already shown how to make this video as well. You can try it on your own, and just do not request for free access. Thank you.